This isn't just a helicopter. Oh no, it's far more than that. It's a flying fortress, a genuine airborne workhorse that can deadlift a medium armored truck, then effortlessly climb to 20,000 feet, and still have the spare power to haul a second truck, or maybe even a small house tucked underneath its belly. This isn't science fiction. It's reality. Meet the Royal Netherlands Air Force CH47F Chinook. We're talking 20 tons of aviation muscle, wrapped around the most advanced digital cockpit ever bolted to a tandem rotor airframe. Today, we're going to tear open every panel, peek into every system, and really show you why this Dutch icon leaves every other heavy-lift rotorcraft gasping for air. Wondering how it does what it does? Picture this for a moment. A single helicopter cutting through the sky lifts a full Dutch artillery piece, when we're talking serious hardware, along with its entire crew. It then navigates 200 nautical miles, not through clear skies, but straight through a blinding, churning sandstorm. It drops that massive gun with pinpoint accuracy onto a dime-sized landing zone in the middle of nowhere, and then, as if it just delivered groceries, sprints home at a blistering 170 knots. Sounds impossible, right? Like something out of a blockbuster movie? Well, for the RNLAF Chinook, that's just a regular Tuesday morning. It's not a fantasy. It's a mission profile. Stay with me, because by the end of this, you'll not only believe it, you'll know exactly how two counter-rotating blades, each powered by a staggering 4,700 horsepower, and one seriously clever, incredibly adaptable cargo floor, turn aluminum and composite into what is, without a doubt, the ultimate multi-mission powerhouse. This isn't just a machine. It's a statement. Section 1. Birth of a Dutch battle wagon. The Netherlands first saw the wisdom in the Chinook way back in 1995. Back then, they were acquiring the D model, a capable machine for its time, but one that still relied on paper charts and those classic steam gauge dials that looked like they belonged in a submarine. Fast forward to today, and what a transformation we've witnessed. The RNLAF now boasts a fleet of 20 upgraded F models. What's truly remarkable is that 6 of these aren't brand new from the factory. They've been meticulously remanufactured, practically reborn, from those very same original D airframes. The genius here is that every single one of them now shares identical cockpits, identical state-of-the-art avionics, and a completely unified suite of self-defense systems. This isn't just about having more helicopters. It's about having a standardized, highly efficient, and incredibly potent fleet. Boeing, the legendary manufacturer, delivered the last new build, Dutch Foxtrot, in 2020, and here's a critical detail. Every single one of these advanced machines rolled off the production line already equipped with the Rockwell-Collins Common Avionics Architecture System, or CAS for short. Now, if you're trying to wrap your head around what CAS means for a pilot, think of it like this. It's the difference between navigating with a clunky, monochrome 1990s Nokia phone and having a sleek, intuitive 2023 smartphone in your hand. Every screen in that cockpit talks seamlessly to every sensor. Every bit of critical flight data is integrated. Every waypoint updates in real time, instantly reflecting changes in the mission. This isn't just about fancy screens. It's about efficiency and safety. Pilots spend significantly less heads-down time fumbling with controls or poring over maps, which means they can dedicate more brain power, more mental bandwidth, to actually flying the mission, assessing threats, and making critical decisions. It's a quantum leap in situational awareness and operational effectiveness, making these Chinooks not just powerful, but incredibly smart. The integration of CAS has fundamentally reshaped how missions are planned, executed, and adapted on the fly, providing a cohesive and comprehensive operational picture that was simply unimaginable with the older D model's analog systems. It's a testament to the RNLAF's commitment to staying at the absolute forefront of military aviation technology, ensuring their crews have every possible advantage in any operational theater. The decision to not just acquire new aircraft, but to systematically upgrade and standardize the entire fleet underscores a long-term strategic vision for heavy lift capability that is both robust and adaptable. Section 2. The Power Story. Let's talk about what makes this beast fly. Tucked away discreetly under the aft pylon, almost like hidden titans, live 2 Lycoming T55GA714A turbines. And when I say turbines, I mean serious powerhouses. Each one of these engines is cranking out a staggering 4,133 shaft horsepower. Do the math, and together, they equal the raw, unadulterated output of about 40 average family sedans. 40! Yet astonishingly, the combined weight of these two colossal engines is less than that of a single pickup truck. That's an incredible power-to-weight ratio, a fundamental ingredient in the Chinook's legendary lifting capability. The T-55 series engines, developed by Honeywell, formerly Lycoming, have a storied history, known for their ruggedness, reliability, and ability to perform in extreme conditions. They are designed to ingest everything from desert sand to Arctic ice, and still deliver consistent, monumental power. This inherent durability is a key reason why the Chinook can operate effectively in such a vast range of global environments, from the scorching heat of Afghanistan to the freezing cold of Norway. But raw power, while impressive, isn't enough on its own. You need to control it, to harness it with surgical precision. That's where the triple redundant digital automatic flight control system, mercifully shortened to DAFCS, comes into play. DAFCS isn't just a fancy autopilot. It's the brain that translates all that formidable horsepower into incredibly precise, almost balletic movements. This sophisticated system allows the Chinook to do things that would make other helicopter pilots sweat bullets. Imagine hovering with half a rotor disc hanging precariously over the edge of a cliff, maintaining perfect stability against unpredictable updrafts and downdrafts. Or picture executing a pinnacle landing on a rooftop no bigger than a tennis court, gently settling 20 tons of metal and cargo onto a tiny patch of concrete. These aren't just parlor tricks. They're critical operational maneuvers in combat zones or disaster relief scenarios. Try attempting that with a conventional tail rotor helicopter, and you'll likely meet gravity and a very unforgiving ground real quick. The DAFCS provides the stability, the responsiveness, and the sheer confidence that allows pilots to push the envelope of what's possible, ensuring the Chinook can deliver its payload or extract its personnel from the most challenging, confined, and dangerous environments imaginable. It's the invisible hand that makes the impossible look routine, turning immense power into controlled grace. Section 3. Tandem rotors. Explained. So, why two rotors? It's one of the first questions people ask when they see a Chinook for the first time. The answer is actually pretty simple. A beautiful piece of engineering elegance based on simple math and physics. Tandem rotors completely cancel torque without wasting a single ounce of precious power on a tail rotor. Think about it. A conventional helicopter needs a tail rotor just to counteract the torque created by the main rotor. Otherwise, the fuselage would spin uncontrollably in the opposite direction. That tail rotor consumes a significant portion of the engine's power that could otherwise be used for lift or forward thrust. On a Chinook, however, every ounce of thrust generated by those powerful engines goes straight into either lifting heavy loads or propelling the aircraft forward at impressive speeds. This design philosophy is what gives the Chinook its unparalleled efficiency in heavy lift operations. The setup is ingeniously simple, yet incredibly effective. The forward rotor spins counterclockwise, while the aft rotor spins clockwise. These two massive discs of spinning blades are perfectly synchronized, and here's a fun fact. The overlap between the two rotor discs is a mere 30 inches. That's less than a meter. The synchronicity, this perfect, intricate dance, comes from a giant, robust, cross-coupling drive shaft that runs the entire length of the fuselage. This drive shaft is the unsung hero, ensuring both rotors always turn at precisely the same speed in their opposing directions. What happens if one engine decides to call it quits mid-flight? This is where the brilliance of the cross-coupling drive shaft truly shines. If one engine fails, the healthy side still drives both rotors. It's designed to provide just enough power, just long enough to get you home safely, or at least to a controlled landing. It's a critical safety feature, a testament to the redundant design philosophy that underpins the Chinook. Each of those massive blades sweeps a 60-foot circle, creating a tremendous amount of lift. Despite its imposing size and incredible lifting capacity, this tandem rotor configuration actually gives the Chinook a surprisingly compact footprint. In fact, its overall length, from the tip of the forward rotor to the tip of the aft rotor, is shorter than that of a Black Hawk helicopter. Yet it boasts double the cargo volume. This combination of powerful lift, compact footprint, and massive internal volume is precisely why the Chinook remains the undisputed king of heavy-lift rotorcraft, capable of operating in confined spaces where other large helicopters simply can't. It's a masterclass in aerodynamic design, proving that sometimes two are indeed better than one, especially when it comes to rotors. Section 4. The cargo cathedral step inside the hold of a CH47F Chinook. And you're not just entering a cargo bay, you're stepping into what feels like a cavernous cargo cathedral. The sheer scale of the space is immediately apparent. It's 9 feet wide, a comfortable 6.5 feet tall, and stretches back a remarkable 30 feet long. To put that into perspective, that's roughly the internal volume of a small city bus. Except, of course, that small city bus can't carry 24,000 pounds of payload, traverse battlefields, or fly through sandstorms. This immense internal volume is one of the Chinook's defining characteristics, making it incredibly versatile for a multitude of missions. The floor itself is a marvel of practical engineering. It's flush-mounted and features an integrated roller system, meaning that heavy pallets loaded with everything from ammunition to medical supplies can literally glide in with just a 2-fingered push. This drastically reduces loading and unloading times, which can be absolutely critical in high-tempo operational environments. Along the walls you'll find flip-up seats. In a standard troop transport configuration, these can accommodate 33 fully equipped combat troops. But the beauty of the Chinook's design is its modularity. Need to evacuate casualties? Simply swap those seats out, and the same space can comfortably fit 24 litters plus 4 dedicated medics to provide in-flight care. It transforms from a troop carrier to a flying ambulance in a matter of minutes. And what about moving something really big? Need to haul a Dutch Fennec reconnaissance vehicle? A crucial piece of battlefield intelligence gathering equipment? No problem. Just drive it right up the wide rear ramp. Once inside, it can be securely lashed down to the heavy-duty tie-down rings, each one rated at an impressive 5,000 pounds. And here's the kicker. Even with a Fennec inside, you've still got room to spare, maybe even enough for the crew's coffee thermos or a few extra supply crates. This isn't just a cargo bay. It's a strategic asset, a mobile logistics hub, capable of moving virtually anything the mission demands, rapidly and efficiently. The ability to quickly reconfigure the interior for different mission profiles, from troop transport to casualty evacuation to heavy equipment lift, is a cornerstone of the Chinook's operational flexibility and why it remains indispensable to the RNLF Section 5 triple hook wizardry. Beneath the Chinook's robust belly lies another one of its signature capabilities, the triple hook system. This isn't just about carrying one external load, it's about unparalleled flexibility and massive lifting power. These 3 cargo hooks can work either in perfect tandem, distributing an enormous load, or completely independently, allowing for multiple, separate sling load operations. The center hook is the real heavyweight, rated for an incredible 12 tons, that's 24,000 pounds. The forward and aft hooks are no slouches either, each capable of handling 4 tons. What does this mean in practical terms? It means you can link all 3 hooks together, creating a formidable lifting platform and sling something truly substantial, like a 7-ton howitzer, a critical piece of mobile artillery, or perhaps 2 Humvees, essential light tactical vehicles, or for a more complex logistical challenge, a mixed load of ammo crates and critical fuel bladders, simultaneously moving different types of supplies to different forward operating bases. The versatility is astounding, but it's not just about brute strength, it's about control and safety. The pilots in the cockpit have an incredibly sophisticated system at their fingertips. They see real-time load angles displayed right on their primary flight displays. This means they know exactly how the external load is behaving, whether it's swinging too much or remaining stable. If the load exceeds a 10-degree swing angle, a critical safety threshold, the system immediately chirps a warning, allowing the pilot to make instant adjustments and prevent dangerous oscillations. Releasing a sling load is equally sophisticated and safe. It's as simple as activating a guarded switch on the collective control. There's no need for a crew member to precariously lean out of the aircraft, battling rotor wash and high altitudes to manually yank a pin. This digital integrated release system enhances safety, speed, and precision, particularly in hostile or challenging environments where every second counts. This triple hook wizardry isn't just a feature. It's a force multiplier, allowing the Chinook to deliver critical assets exactly where and when they're needed, with unmatched efficiency and safety. Section 6. The digital cockpit. Stepping into the cockpit of the RNLAF CH47F is like entering a command center from a futuristic movie. Gone are the days of cluttered dials and analog gauges. Instead, 4 stunning 8 by 10-inch color screens completely dominate the instrument panel. These aren't just displays. They're windows into the aircraft's very soul and the operational environment around it. The outer 2 screens are dedicated to primary flight data, giving pilots all the essential information they need at a glance: airspeed, altitude, attitude, and navigation. The inner 2 screens, however, are where the true flexibility comes into play. These are user-selectable, meaning pilots can configure them to display exactly what they need for a specific phase of flight or mission. This could be a detailed moving map, engine instruments with real-time performance data, intricate sling load symbology that graphically depicts the external load's behavior, or a comprehensive status report of the defensive suite. It's about presenting the right information at the right time, minimizing cognitive load. Of course, redundancy is key in aviation, so a pair of standby gauges sits discreetly in the middle of the panel. But let's be clear, they are literally the last resort, only used in the unlikeliest of system failures. The real magic, however, extends beyond the main instrument panel. Pilots wear advanced Gen 3 helmet-mounted displays. These aren't just fancy goggles. They project critical flight information directly onto the visor, right in the pilot's line of sight. Imagine seeing the horizon line, altitude, airspeed, and even infrared imagery from the nose-mounted MX-15 sensor ball overlaid onto your natural vision, regardless of where your head is turned. Night flight, which used to be a terrifying ballet of flashlights, paper maps, and straining eyes, has been utterly transformed. Now it's a heads-up, eyes-out experience. The helmet display can project synthetic terrain, glowing green on the visor, allowing pilots to see the ground contours and obstacles even in pitch-black conditions or through adverse weather. This dramatically enhances situational awareness, reduces workload, and significantly improves safety during low-light or zero-visibility operations. The CAS, Common Avionics Architecture System, is the backbone of this integrated cockpit, allowing seamless communication between all these systems. It's not just about displaying data. It's about processing, fusing, and presenting it in an intuitive, actionable way. This level of integration allows pilots to maintain superior situational awareness, make faster, more informed decisions, and ultimately, execute complex missions with a level of precision and confidence that was simply impossible in earlier generations of rotorcraft. It's a testament to how far aviation technology has come, turning what was once a demanding analog task into a highly automated, digitally assisted art form. Section 7. Self-defense Dutch style from the outside. The unparalleled Chinook might look like a big friendly giant, a benevolent workhorse designed purely for transport, but don't let that unassuming exterior fool you. Tuck yourself under its belly, and you'll find a sophisticated array of self-defense systems designed to keep this flying fortress and its precious cargo safe in hostile skies. It's a testament to the reality of modern military operations. Even a transport helicopter needs to be able to defend itself. First up, there's the ANR-57 missile launch detector. This isn't just a simple warning system. It's an advanced electro-optical sensor that can detect the telltale heat plume of an incoming missile almost instantaneously. Once a threat is detected, the Chinook isn't left defenseless. It carries multiple chaff and flare dispensers. Chaff, essentially tiny strips of aluminum or fiberglass, creates a massive radar signature to confuse radar-guided missiles, making the Chinook disappear in a cloud of false targets. Flares, on the other hand, are super-hot pyrotechnic devices designed to lure heat-seeking missiles away from the aircraft's engines. It's a classic bait-and-switch, and it's incredibly effective. But the Dutch have taken it a step further with the Bright Cloud expendable decoy. This is a truly cutting-edge piece of technology. Bright Cloud is a compact active radar jammer that can be ejected from the aircraft. Once deployed, it actively mimics the radar signature of a much larger aircraft, or creates multiple false targets, effectively spoofing radar-guided missiles and disrupting enemy targeting systems. It's like having a digital ghost that draws enemy fire away from the real aircraft. Up top, the enhanced radio altimeter isn't just telling the pilot how high they are. It's pinging the ground in 4 different directions. Why? Because this provides critical terrain following cues, allowing the crew to literally duck under enemy radar by flying extremely low, hugging the contours of the Earth. This ability to fly nap of the Earth, NOE, is a crucial survivability tactic in contested airspace. And while the Chinook is primarily a transport, It can still bite back. 3 pintle mounts accept 7.62mm FN mag machine guns, one on each side door, providing lateral defense, and a third at the rear ramp, covering the vulnerable aft sector during approach or departure. These guns are purely defensive. The Chinook isn't looking for a fight. But as proved time and again in Afghanistan, they were more than enough to keep hostile forces heads down, providing critical suppressive fire and allowing the Chinook to slip in and out of hot zones, delivering or extracting personnel and equipment under immense pressure. It's a comprehensive, layered approach to self-defense, ensuring that the RNLF Chinook remains resilient and effective even when operating in the most dangerous environments. Section 8. Real missions. Real places. The true measure of any military aircraft isn't its specifications on paper, but what it does when the stakes are highest. And the Dutch Chinooks have proven their mettle countless times in real missions, in real places under unimaginable pressure. Since 2001, these workhorses have logged more than 40,000 combat hours in Afghanistan, a testament to their relentless operational tempo and unwavering reliability in one of the world's most challenging theaters. Their missions there were as varied as they were vital. They inserted special forces teams deep into the rugged, unforgiving terrain of the Hindu Kush Mountains, often at night, often into unsecured landing zones, providing the silent hand that enabled covert operations. They extracted wounded Danish troops under intense enemy fire, their powerful engines and robust airframe shrugging off small arms impacts, ensuring that injured personnel received critical medical attention as quickly as possible. And in a feat of logistical brilliance, they ferried heavy Dutch PZH 2000 howitzers across mountain passes that were simply too high, too steep, and too dangerous for any ground vehicle. The Chinook literally became the lifeline, enabling artillery support in a land defined by its vertical challenges. But their heroism isn't limited to combat zones. In 2013, when Typhoon Haiyan unleashed its catastrophic fury on the Philippines, a pair of RNLAF F models were among the first responders. They moved an astonishing 40 tons of relief supplies, flying 14-hour days, operating tirelessly from an Australian amphibious ship, a floating base of operations in the midst of utter devastation. They delivered food, water, medicine, and shelter, bringing hope to communities utterly cut off by the storm. Perhaps one of the most poignant examples of their indispensable role came in 2021 during the chaotic evacuation from Kabul. 3 Dutch Chinooks were instrumental in plucking more than 500 desperate evacuees from a rooftop in the besieged city. Think about that, squeezing 60 souls per flight into a cargo bay originally designed for 33 combat troops. This wasn't about adhering to specs. It was about saving lives. It was raw courage and adaptability. Proof that when lives are on the line, when humanity calls, paperwork specs go right out the window. The crews pushed the limits, demonstrating the inherent flexibility and sheer capacity of the Chinook, turning it into a literal ark of safety amidst chaos. These are not just anecdotes. They are powerful illustrations of the Chinook's multi-mission capability, its rugged reliability, and the profound impact it has on the lives of soldiers and civilians alike, wherever it deploys. Section 9. Maintenance hacks. A powerful aircraft is only as good as its maintenance, and the RNLF, with its characteristic pragmatism and ingenuity, has developed some truly impressive maintenance hacks that keep their Chinooks flying with remarkable efficiency. These aren't just minor tweaks. They're fundamental design advantages and clever operational procedures that maximize uptime and minimize downtime. One of the most impressive features is how the engines are maintained. Every 400 flight hours, when routine maintenance is due, the engines don't require the complex, time-consuming process of removing the rotor mast. Instead, they simply roll out on rails, smoothly sliding out of their compartments, allowing maintenance crews unimpeded access. This drastically cuts down on the labor and specialized equipment required for engine work. Similarly, the ingenious design includes a hinged aft pylon. This isn't just for show. It allows maintainers to tilt the entire rear transmission down, providing clear, unhindered access to the critical drive shaft couplings. This kind of accessibility is a dream for mechanics, making what could be complex, cramped tasks much simpler and faster. Dutch crews, known for their meticulousness and efficiency, pride themselves on a 24-hour engine swap record. Think about that. An entire engine removed and replaced and the aircraft ready to fly in just one day. Most NATO partners, even with their own highly trained crews, typically need twice that time, sometimes more. This kind of rapid turnaround is not just about bragging rights. It's about operational readiness, ensuring that aircraft are available for missions when they're most needed. Beyond immediate repairs, the RNLAF also has a smart logistical strategy. A 4-year maintenance, repair, and overhaul (MRO) contract with AAR Corp. ensures that crucial auxiliary power units (APUs) are refurbished and maintained in country. This means no Chinook sits grounded for weeks or months, waiting for a shipping container carrying a critical part to arrive from the States. By keeping these essential components within the national supply chain and expertise, the Netherlands drastically reduces logistical bottlenecks and ensures a higher state of readiness for its entire fleet. These maintenance hacks are a testament to the RNLAF's dedication to operational excellence, transforming complex maintenance into streamlined, efficient processes that keep their flying fortresses in the sky, ready for anything. Section 10. Future-proof the Royal Netherlands. Air Force isn't just flying these Chinooks for today. They're investing in their future. The plan is to keep these incredibly capable airframes flying until at least 2045. That's a remarkable lifespan for any military aircraft, and it speaks volumes about the Chinook's inherent design strength and adaptability. To achieve this longevity, a continuous program of midlife upgrades is already well underway, ensuring the fleet remains at the cutting edge of heavy lift technology. One significant upgrade already in the pipeline involves an advanced rotor blade cuff design. This isn't just a minor tweak. It's engineered to cut vibration by a substantial 15%. What does that mean in real terms? Reduced vibration translates directly into less crew fatigue on long missions, which is a huge factor for safety and effectiveness. It also significantly extends the lifespan of the transmission and other critical airframe components, reducing wear and tear and lowering maintenance costs over the long run. It's a win-win for both the operators and the maintainers. Looking further ahead, engineers are exploring even more innovative enhancements. Next-generation self-sealing fuel tanks are being developed, designed to withstand battle damage more effectively and reduce the risk of fuel leaks. And in a nod to advanced manufacturing, a 3D printed titanium cargo ramp is on the horizon. These upgrades aren't just about cool technology. They're about practical improvements. Together, they promise to shave another 200 pounds off the aircraft's empty weight. 200 pounds might not sound like much on a 20-ton helicopter, but it's crucial. That weight saving directly translates into increased payload capacity, allowing future crews to haul an extra stretcher for a casualty or an additional mortar round for ground forces, potentially making a critical difference in a mission. And here's where it gets really interesting. Rumor has it, and where there's smoke, there's often fire in military aviation circles, that the Dutch are eyeing the same Block 2 upgrades that the U.S. Army recently ordered. These Block 2 enhancements are truly transformative. They would bump the Chinook's already impressive max gross weight from 54,000 pounds to a colossal 62,000 pounds. What could you do with that kind of extra lifting power? Well, among other things, it would be enough to sling a Patriot missile launcher, a critical air defense system, into virtually any location. This kind of strategic capability would fundamentally alter the dynamics of rapid deployment and force projection. The RNLAF's commitment to continuous modernization ensures that their Chinooks won't just endure, they'll evolve, remaining a dominant force in heavy lift aviation for decades to come, ready to tackle whatever challenges the future holds. Mid-roll CTAI if you're finding value here. If this deep dive into engineering and operational prowess is hitting the mark, then please take a second and tap that like button. It truly tells the algorithm that real engineering, genuine capability, and in-depth content matters more than just quick reaction videos. And while you're at it, smash that subscribe button and hit the notification bell, because next week, we're doing something epic. We're climbing inside the cockpit of the upcoming CH-53K King Stallion to see if it can truly dethrone the legendary Chinook. You won't want to miss it. Section 11. Pilot Perspective. To truly understand an aircraft, you need to hear from the people who fly it, who push its limits every single day. I had the incredible privilege of sitting down with Major Anneliese van der Berg. a remarkable pilot and one of only 5 female Chinook pilots in the entire Royal Netherlands Air Force. Her insights were invaluable. She told me with a wry smile that the hardest part of flying the Chinook isn't necessarily managing a 12,000-pound sling load once it's stable and flying. No, she explained. The real challenge, the moment that demands absolute focus and precision, is those first 30 seconds after takeoff. That's when the external load, a massive pendulum hanging beneath the aircraft, decides whether it's going to behave like a perfectly docile weight or an unpredictable, destructive wrecking ball. Her trick, honed over countless hours of intense training and real-world missions. Breathe, she advised. Hold a constant 50-foot climb and above all trust the flight control computers. It's a testament to both her skill and the sophistication of the DFCS system. It's a delicate dance between human input and machine precision, where the pilot provides the intent, and the computers translate it into flawless execution. Major Vanderberg also openly admitted something quite telling about the F model's advanced cockpit. It's so automated, so incredibly intuitive and efficient, that on routine flights, when the mission profile allows, she actually has time to snap photos of the breathtaking northern lights over Norway. Think about that for a moment. This is something the old D model, with its constant need for manual input and its analog needles dancing nonstop, would never ever have allowed. The level of heads-down time required for navigation and systems management in the older aircraft simply didn't permit such moments of awe or even simple observation. The modern cockpit isn't just about making the job easier. It's about freeing up the pilot's cognitive capacity, reducing workload, and allowing them to focus on the bigger picture, the mission, and yes, sometimes even appreciate the extraordinary views from 20,000 feet. It fundamentally changes the pilot's experience, transforming a demanding, all-consuming task into a more manageable, and at times, even enjoyable one, without compromising safety or effectiveness. Section 12. The price tag. Let's talk brass tacks and budget. The unit flyaway cost for a brand new factory-fresh CH47F Chinook sits around $41 million. That's a significant sum, no doubt. But for the Royal Netherlands Air Force, that's just the starting point. When you factor in all the Dutch-specific communication suites, the highly customized defensive systems tailored to their operational needs, and the necessary spares package to ensure operational readiness for years to come, the sticker price climbs to roughly $55 million per copy. Again, a substantial investment. However, sticker price alone doesn't tell the whole story, especially when you're talking about military assets. The real measure of value often comes down to capability per dollar. And this is where the Chinook's math starts to look incredibly favorable. Let's divide that $55 million price tag by its maximum payload capacity, roughly 24,000 pounds. What you get is approximately $2,300 per pound of lift capability. Now let's compare that to another formidable military helicopter, say, a $40 million Black Hawk. A Black Hawk is an amazing utility helicopter, but it lifts about 4,000 pounds externally. Do that math and you're looking at $10,000 per pound of lift. Suddenly, the Chinook's $55 million price tag doesn't just look reasonable. It looks like an absolute bargain. You're getting significantly more lifting power, more range and more versatility for a fraction of the cost per pound. This cost-effectiveness, combined with its multi-mission capabilities, makes the Chinook a strategically sound investment for any nation requiring serious heavy lift capabilities. It's not just about buying a helicopter. It's about acquiring an unmatched logistical and operational advantage. And when you crunch the numbers, the Chinook delivers exceptional value for its unparalleled performance. Section 13. Competition check. So, how does the venerable Chinook stack up against the competition, especially in a rapidly evolving aerospace landscape? It's a fair question, particularly with newer designs entering the market. Let's look at Europe's new kid on the block, the Airbus H225M Caracal, or America's upcoming, revolutionary V280 Valor tilt rotor. The Airbus H225M is a very capable, modern helicopter, but it carries about 3 tons less payload than the Chinook. It does, however, have a distinct advantage. Its design allows it to land safely on oil rigs, a critical capability for offshore operations and specialized maritime roles. So for specific niche missions, it certainly has its place. Then there's the V280 Valor, A truly exciting piece of technology. This tilt-rotor aircraft flies twice as fast as any conventional helicopter, offering unprecedented speed and range for vertical lift. It's a game-changer for rapid insertion and extraction. But here's the catch. As of now, it can't yet sling a 7-ton howitzer, or anything close to the kind of heavy, bulky loads that the Chinook routinely handles. The Valor represents the future of speed, but the Chinook remains the present and foreseeable future of pure, brute force heavy lift. When you look at raw ton miles per gallon, a critical metric for logistical efficiency, the Chinook still unequivocally wins. Its tandem rotor design offers a distinct aerodynamic advantage. Tandem rotors create significantly less downwash than a single main rotor of equal lifting area. Why does this matter? It means Dutch crews can drop pallets of aid, equipment or troops into tight jungle clearings, or onto unprepared fields, without blowing away the very villagers they're trying to help, or kicking up a blinding dust storm that compromises visibility and operational safety. This reduced downwash is a subtle but profound advantage, making the Chinook a more environmentally considerate and tactically flexible aircraft, especially in humanitarian aid or special operations scenarios where minimizing ground disturbance is crucial. While newer designs offer specialized advantages, for sheer heavy lift, operational versatility, and cost-effectiveness, the Chinook continues to hold its own, proving that a proven design, continuously upgraded, can remain fiercely competitive. Section 14. Training days. Becoming a Chinook pilot isn't for the faint of heart. It demands rigorous training, precision, and an unwavering commitment to excellence. Dutch Chinook pilots, rather uniquely, train at Fort Novosel, Alabama, right alongside their U.S. Army counterparts. This isn't just a casual exchange program. It's a fully integrated, intense training regimen. The syllabus is virtually identical for both nations' pilots, right up until the final 2 weeks of the program. This shared foundation ensures a high degree of interoperability and common understanding of procedures, which is vital for NATO operations. In those crucial final 2 weeks, the Dutch pilots diverge for specialized training, tailored to their specific operational environment and national requirements. This includes intensive mountain training in the rugged, unpredictable terrain of the European Alps, honing their skills in high-altitude, confined area operations. They also undertake critical deck landing qualifications aboard the HNLMS Carol Doorman, the Royal Netherlands Navy's large support vessel. Mastering the art of landing a 20-ton helicopter on a pitching, rolling ship deck in varying sea states is an advanced skill that requires immense precision and nerves of steel. Before a pilot ever touches the controls of a real Chinook, they log at least 100 hours in an advanced simulator. And these aren't just glorified video games. These simulators are incredibly sophisticated, hyper-realistic environments that can throw every conceivable challenge at a pilot. Imagine the scenario: rotor blade icing accumulating rapidly, dual engine failure at max gross weight over hostile territory, or a sling load snarl at 200 feet, threatening to destabilize the aircraft. The simulator allows pilots to experience and overcome these catastrophic emergencies in a safe, controlled environment. Crash virtually, and you simply get another try, learning from your mistakes without real-world consequences. Crash for real, however, and there are no extra lives. This intensive, realistic simulation training is a cornerstone of the RNLF's pilot development, ensuring that when their pilots take to the skies in a real Chinook, they are not just proficient, but supremely confident and capable of handling anything the mission, or fate, might throw at them. Section 15. Civilian side hustles. While the Chinook is undeniably a military workhorse, a flying fortress built for defense and combat, its immense capabilities aren't confined to the battlefield. When not engaged in military exercises or deployments, Dutch Chinooks routinely lend their incredible strength and versatility to civilian authorities, transforming into powerful tools for humanitarian aid and disaster relief right at home. This civilian side hustle showcases the true multi-mission nature of the aircraft and its importance to the Netherlands. Consider the devastating floods that swept along the Meuse River in 2021. The Chinooks were there, dropping massive sandbags with pinpoint accuracy to reinforce crumbling dikes and prevent further inundation. They airlifted critical refrigerated trucks to broken dikes, ensuring essential supplies could reach isolated communities. These weren't just simple lifts. They were complex, low-altitude precision operations, often in challenging weather, demonstrating the pilot's skill and the aircraft's stability. And for a truly unique mission, imagine moving a 600-year-old church bell when a conventional heritage restoration crane simply couldn't reach the belfry of an ancient church. The Chinook stepped in. With its precise lifting capabilities and stable hover, it carefully plucked the massive bell from its perch, a delicate operation that required immense skill and a gentle touch. This kind of mission highlights the Chinook's adaptability beyond its military role. The Dutch public, it seems, has a genuine affection for their Chinooks. Kids wave enthusiastically from bike paths as the powerful helicopters fly overhead. Farmers, often seeing them hover over soggy fields during flood relief efforts, have even been known to offer fresh stroopwafels to the grateful crews. It's a testament to the positive impact these aircraft have on civilian lives, forging a unique bond between the military and the populace. Try getting that kind of reception with a fighter jet. The Chinook isn't just a weapon system. It's a symbol of aid, resilience, and national pride, demonstrating its value far beyond traditional military applications. Section 16. Environmental tricks. In an era of increasing environmental consciousness, even military aviation is looking for ways to reduce its footprint. The venerable Lycoming T-55 engine in the Chinook, while powerful, is traditionally a thirsty beast burning standard Jet A fuel. However, the RNLF is at the forefront of exploring more sustainable options. The good news is that the T-55 is incredibly adaptable. It also readily accepts sustainable aviation fuel, SF blends up to 50%, without any modifications to the engine itself. RNLF ground crews, ever practical, report no discernible power loss when operating with these biofuel blends. What they do notice, however, is a rather charming side effect: a faint, almost nostalgic French fry smell at startup. It's a small detail, but a tangible sign of progress towards greener aviation. This capability isn't just about PR, it's about reducing carbon emissions and enhancing energy security by diversifying fuel sources. But the innovation doesn't stop there. Engineers are actively testing a new compressor design for the T-55 engine. This advanced compressor promises to cut specific fuel consumption by an impressive 8%. 8% might not sound like a headline-grabbing number, but in military aviation, it translates directly into significant operational advantages. For the Chinook, an 8% reduction in fuel burn means stretching its combat radius from an already respectable 400 nautical miles to roughly 430 nautical miles. That extra 30 miles might not sound sexy to the casual observer, but for a mission planner, it's a critical margin. It could be the difference between needing to refuel in hostile, unsecured territory versus making it back to friendly forces or a secure forward operating base. It means greater operational flexibility, reduced risk for crews, and ultimately more effective mission accomplishment. These environmental tricks aren't just about being green. They're about enhancing the Chinook's operational effectiveness and ensuring its relevance in a changing world, proving that sustainability and capability can go hand in hand. Section 17. The soundtrack. Every aircraft has its signature sound, and the Chinook's is utterly unmistakable. It's that deep, resonant, almost primal whop-whop that sounds like a drum solo played through a massive subwoofer. It's a sound that announces its presence long before you see it. A sound that inspires both awe and, for some, a touch of trepidation. But why does it make that unique noise? The answer lies in the fascinating physics of its tandem rotor system, and specifically the blade tip speed. Each of those massive rotor blades is traveling at incredible velocity, just under Mach 0.9. That's nearly the speed of sound. When the blades of the forward rotor pass through the turbulent wake created by the aft rotor, they're essentially slicing through disturbed air. This interaction creates a distinct pressure wave, a percussive effect that propagates as that iconic whop-whop sound. It's the audible signature of extreme power and aerodynamic forces at play. While distinctive, this powerful acoustic signature can be incredibly noisy, both for those on the ground and, critically, for the crews inside. To combat this, Dutch acoustic engineers, always looking for an edge, have fitted serrated trailing edge cuffs to the rotor blades. This innovative design, inspired by nature, think owl feathers, helps to smooth the airflow and reduce the turbulent interaction. The result? A significant reduction in interior noise by 4 decibels. 4 decibels might not sound like a lot, but for human hearing, it's a noticeable difference. It means that crews can now speak in normal voices while wearing their helmets, rather than having to shout over the din. This reduction in noise isn't just about comfort. It reduces crew fatigue on long missions, improves communication, and ultimately enhances overall mission effectiveness and safety. It's a subtle but significant improvement that makes a tangible difference to the people who operate this magnificent machine. Section 18, Speed Record While. The Chinook is renowned for its lifting power. It's no slouch when it comes to speed either. In 2019, a Dutch Chinook quietly set an unofficial speed record for the type, pushing the envelope of what this tandem rotor marvel could achieve. Flying down the east coast of England, aided by a brisk 20-knot tailwind and carrying a relatively light fuel load, it hit an astonishing 196 knots indicated airspeed. That's over 360 kilometers per hour, a blistering pace for a heavy-lift helicopter. Engineers who designed the Chinook have always speculated that the airframe could theoretically break the 200-knot barrier. However, there's a critical aerodynamic limit at play. If the rotor tips were to enter the transonic range, the point where airflow around the tips starts to approach and then exceed the speed of sound, it could induce severe vibrations, structural stresses, and potentially start shaking rivets loose. That's not a desirable outcome for any aircraft, let alone one designed to carry precious cargo and personnel. So while the theoretical speed might be slightly higher, the pilots, with their inherent understanding of the aircraft's limits and a healthy respect for physics, wisely throttled back at 196 knots. They were more than happy to keep their wings, or in this case their rotor blades, firmly attached. This unofficial record isn't just a fun fact. It demonstrates the immense power and aerodynamic efficiency inherent in the Chinook's design, proving that this heavy lifter can also move with surprising agility and speed when the mission demands it. It's a testament to the aircraft's robust engineering and the skill of the RNLAF pilots who push its capabilities responsibly. Section 19, Export Success. The operational prowess and innovative maintenance practices of the Royal Netherlands Air Force Chinook fleet haven't gone unnoticed by the international community. In fact, their model has become a blueprint for excellence, leading to significant export success and international collaboration. Belgium, Spain, and even far-off South Korea have all recognized the value in the Dutch approach and have sent their own pilots to train with RNLAF instructors. The RNLAF runs a highly regarded 6-week exchange program, specifically focused on advanced sling load techniques, particularly in confined areas. This is where the Dutch expertise truly shines, as they've mastered the art of precision heavy lifting in challenging environments. The benefits of this training are clear and immediate. Just last year, a South Korean crew, fresh from their exchange with the Dutch, successfully delivered a vital replacement generator to a wind farm platform in the notoriously rough North Sea. This was a mission that would have been virtually impossible for their older Seahawk helicopters, which lacked the Chinook's lifting capacity and stability in such demanding conditions. The success of these international partnerships and the proven effectiveness of the Dutch training methodology means that the RNLAF model is rapidly becoming the de facto NATO syllabus for heavy lift rotorcraft operations. It's a testament to their leadership in this specialized field, fostering interoperability and raising the bar for heavy lift capabilities across allied nations. This isn't just about selling helicopters, it's about sharing knowledge, building stronger alliances, and ensuring that partner nations can execute complex, heavy lift missions with the same level of precision and confidence that the Dutch have cultivated. The RNLAF Chinook isn't just a national asset, it's an international benchmark. Section 20, Final Burn from the towering, unforgiving mountains of Afghanistan to the low-lying, often flood-prone plains of the Netherlands. The CH47F Chinook has become far more than just a helicopter. It has evolved into a symbol, a flying promise. It's a promise that Dutch soldiers, wherever they may be deployed, will never be out of reach, that resupply and extraction are always within the realm of possibility, no matter how remote or dangerous the location. It's a promise that disaster victims, cut off and vulnerable, will see vital supplies overhead before despair has a chance to fully set in, a beacon of hope descending from the sky. And perhaps most powerfully, it's a promise that when something absolutely, positively has to be there tomorrow, against all odds, through any obstacle, those distinctive tandem rotors will beat the sunrise, delivering on that commitment. The Chinook isn't just a machine of war. It's a machine of life, of logistics, of humanitarian aid, and of unwavering support. It embodies resilience, capability, and an enduring legacy of service. It's a testament to the ingenuity of its design and the dedication of the crews who fly and maintain it. Outro. So, next time you hear that echoing thud in the distance, that deep, rhythmic whoop-whoop reverberating through the air, don't just dismiss it as another aircraft. Look up. It might be a lumbering cargo plane slowly making its way, or, just possibly, it might be the Netherlands' flying fortress, the ultimate CH47F Chinook, defying gravity and logic, hauling impossible weight to impossible places, a testament to what dedicated engineering and human courage can achieve. Either way, you now know exactly what makes this ultimate CH47F Chinook tick, what lies beneath that powerful, distinctive sound. If this video has armed you with knowledge, if it's given you a deeper appreciation for this incredible machine, then do us a favor, drop a like, subscribe to the channel, and share it with that friend who still thinks helicopters work like magic. Until next time, keep your heads up and your rotor blades level.